tell him that may be a good thing, because without imperfection, neither you nor I would exist.
$13.5 billion years ago, the universe was mostly hydrogen gas, with gravity doing what gravity does, which is to slowly pull it into vast clouds. Hydrogen is the simplest of gases, but it has a very special property. It's a tremendous source of power. Heat hydrogen to around 10 million degrees and it begins to produce the energy that makes the stars shine and supplies the universe with warmth and light. To see how this works, let's imagine we could make a small star here on Earth. First, we need plenty of hydrogen gas. About a sports stadium full would be perfect. Next, we need to imagine squishing this hydrogen together, just as gravity does in space. As the hydrogen compacts, the atoms of gas start bouncing off each other, and the temperature begins to rise. By the time it's compressed down to the size of a soccer ball, the hydrogen reaches the critical 10 million degrees, and a process called nuclear fusion begins. The hydrogen starts to fuse together, making a new, heavier material, helium. With every step of this tiny bump and grind, some matter gets converted into pure energy. We have created a miniature star. Of course, if this was a real experiment, you wouldn't want to go anywhere near it. The energy given off, even from a star this small, would be devastating. Back in the early universe, the same process happened for the first time on a much, much bigger scale. Gravity compressed the hydrogen gas clouds over millions of years until deep in the center, the hydrogen became hot enough for fusion to occur. The first star burst into life, pouring its energy into the vast universe. A product of the laws of nature and the raw materials left over from the Big Bang. It was almost 1,000 times bigger than our own sun and burnt a deep blue. What's more, this star soon had company. The stars were turning on. This same process still happens in our sun, which is where we get the energy we need to live. But there was still a long way to go to get from this to where we are today. You can't build a world like ours from simple gases, such as hydrogen and helium. you need all sorts of other elements. You need elements like oxygen and carbon and iron and many more. But we got lucky yet again, because the very same process that causes the stars to shine also just happens to make materials like oxygen and carbon and iron. Stars, simply by accident, are giant factories. To see a star in action, let's imagine I could split one in half. Just as in the soccer ball star, the hydrogen atoms are fusing together, creating helium, which produces the star's energy. But helium is slightly heavier than hydrogen, so it sinks to the center of the star. And now the helium atoms take center stage. As they fuse together, they produce even more energy and form yet another new element, carbon, a vital building block of every living thing. The process repeats itself over and over, and the star becomes layered like an onion. A really big onion. The closer to the center, the heavier the elements, like neon, oxygen, and last of all, iron. Now things change. Iron doesn't produce energy when it fuses, so the fire begins to go out. More and more iron builds up in the star's core until almost all the remaining fuel runs out. Now gravity takes over and squashes the star in on itself. As its core gets more and more compressed, its temperature soars until it's over 100 times hotter than the core of our own sun. Finally, the star collapses and explodes. This is a supernova. The death of a star and the birth of something new. In these brief microseconds, a massive shockwave passes through the star. The blast is so powerful that it forces some of the iron to fuse into even heavier elements. And that's how heavy elements, such as gold or platinum or lead, are made, forged in the heart of an exploding star. So if you have a gold ring, make sure you appreciate it. The metal was made in a blinding flash of light billions of years ago. The finale of the process that produced the elements all around us today. It never ceases to amaze me that our bodies are constructed of the stuff of the stars,
and that our hearts beat because of the energy given off as those materials are made. But as magical as a star is, there are even more fascinating and powerful things in our enormous cosmos.
Around 300 million years after the Big Bang, the early stars began to form galaxies, which slowly took on a bewildering variety of shapes and sizes. Our galaxy, the Milky Way, is thought to be one of the oldest. having started to assemble itself some 13 billion years ago. It's roughly 6,000 billion miles in diameter and contains something like 200 billion individual stars. Nobody's quite sure exactly how many, since they can't all be seen from Earth, and anyway, it would take a long time to count them. Because all these stars were built by gravity, you could say gravity's the hero of the universe. After all, it turned a meaningless soup of gas into something of beauty and power. But like all interesting heroes, gravity has its dark side. Right in the center of our galaxy lies an example of what happens when gravity rules unchallenged. A black hole. When I was in my 20s, I did some of the basic
Mathematics of black holes, but few people shared my fascination. These days, they are a popular subject.
physicists